Okay, so today we are going to solve LeetCode 136, which is called the single number. So the question goes, given a non-empty array of integers, every element appears twice except for one. Find that single one. So let's see some examples. In this example, as you can see, 2 occurs twice and 1 occurs just once, so the answer is 1. In this example, 1 occurs twice, right here, and 2 occurs twice, but 4 occurs just once, which is the answer. So there is a note here. It says your algorithm should have linear runtime complexity, which we can't obviously. Could you implement it without using extra memory? This part will require some little trick from mathematics. So let's start with a naive solution without this constraint. So we will solve the problem with on time and on memory. So how we are going to do is we are going to keep the number of occurrences of each element and return the element with just one occurrence. It's obvious. So how we are going to do it is we are going to use an unordered map or a hash map in other languages. So, and then we will just update the occurrence number of each element, and then we will return the element with occurrence number 1. So let's code it. So we are going to have an int unordered map, which is going to have key as an integer and value as an integer. So let's just iterate through our array, which is called nums. And then we are going to just update the occurrence number like this. We're just going to increase the number because there is no decreasing here. And then we are just going to iterate through the unordered map here. So iterator is going to start from the beginning. And unless it is equal to unordered map's end pointer, we are good. So we are just going to do it like this. This is how you traverse an unordered map, or other kind of data structures as well, like map, set, etc. So we are going to check if unordered map, well, we can do it with just pointer. So if the value of the thing here, iterator, has a pair, and the second one, which is the value, this one, if it is equal to 1, then we are just going to return iterators first, which is going to be the value itself, key itself, sorry. And then let's say we return -1 so that it do not return a warning or error. So let's start the code and see if this works. So apparently it works in this example. Let's submit it. And yeah, our code works, but apparently the space complexity is not optimal because we are faster than only 13% of all codes. So what we are going to do is to return this and make this O1 space complexity. We are going to apply some tricks so that it do not make any noise. So let's move on. What we are going to do here is that we are going to use the properties bitwise XOR. Properties of bitwise XOR operator. So what does this do? Let us analyze this on just two numbers. Let's say this is our first number and this is our second number. So when we XOR these two, we just return 0 for the bits that are having the same value, and we are just going to return 1 for the bits that have different value. So apparently if two bits have different value, one of them has to be 1 because there's only two values a bit can take. So whenever we see a 1 and a 0, it returns 1. It's here, 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 and this is going to be a 0 because two bits are the same, and here, here. So this is going to be our XOR, and apparently we can make some observations. We can show that any number when XORed with 0 is going to give that number itself, right? Because only the bits that have one value will have to differ with a 0 string. Let's say we have this. Apparently the bits that differ are the bits that have value 1. So it's going to be the same with this number. So we know this, and also we know another thing, right? We know this. We know that any number when XORed with itself is going to return 0 because all the bits are the same. And let's add one more property, and then we can jump into the solution itself. We are able to show that any number when they are XORed have a result, and when we XOR this with another number, another integer, let's say, it will be, let's say, like this. I mean, the order doesn't matter. That's what we are trying to show here. Okay. When we know this, we can notice something else. If two numbers are the same, they return 0, right? And if a number is a number, well, and there is a 0 when XORed with each other, it will return the number. So if I keep a value of 0, let's say x is 0, okay, and then I update x whenever I see x is equal to x with let us call our we have array name nums I, then we are just going to see that this thing 0 will become the number itself. Then when we see that number again, if it has a duplicate, then our result will be 0 as well. Let us show this in an example. Let me take an example here. Let's say this is our example, and apparently x is 0, and let's update x itself. Okay, x is 0, and when I XOR this with 4, it's going to become 4 because of this property. And then when I XOR this with let us actually start with this number, and let's take 4 at the end. So when I XOR this with 1, it will become 1. When I do it with 1 again, because the order doesn't matter, it will become 0. When I do it with 2, it will become 2. When I do it with 2 again, it will become 0 again. So only the number itself will appear at the end, the number that occurs just once. So let's code it without waiting too much. So we're just going to do it like this, and x is going to be equal to x XOR I, right? Okay, so let me do it like this, and I am going to return x. That is going to be the result, and as you can see, we have only 4 lines of code right here. So let's see if this works, and submit it. And apparently it's fast, and it is better in space complexity because it has O1 space complexity. We just keep a value, a parameter here. And that's it. Thank you very much for watching.